Hi everyone, I'm Jeff from eyeon Software. In this tutorial, I'm going to show you the Volume Fog tool. It's one of the trio of position tools in Fusion. Let's begin. Fog effects can be generated in a number of ways in Fusion. The 2.5-dimensional method is achieved with the original fog tool. This fog requires an image with embedded Z-channel data to generate a simulated fog. Another method specifically designed for 3D scenes is the 3D fog tool, with similar color and image input controls as its cousin, but the 3D version takes advantage of a 3D scene created or imported into Fusion. The Volume Fog tool is used to create sophisticated volume fog on images containing X, Y, and Z position data, derived from a world position pass. The Volume Fog tool works on 2D images and delivers much faster results and interactive feedback when setting up the fog. This is heavily dependent on OpenCL and the qualifications of your display card. Depending on the graphics card used in the computer, you can boost the speed of the tool by a factor of 30 or even more. Let me show you how this works. With the Volume Fog tool, you begin with a 2D image format, and as I stated earlier, you require World Position Pass output. The World Position Pass needs to be rendered in 32-bit float to provide the accuracy needed. In our example, we'll take the 3D Beauty Pass render and the accompanying World Position Pass render generated from a 3D application. The first step is to embed the World Position Pass into the RGB Beauty Pass render. You'll require a Channel Booleans tool, which can be found under Tools, Color. Here's how you do it. First, connect the output of your Beauty Pass RGB render into the background input of the Channel Boolean tool, and connect the World Position Pass render to the foreground input. Let's set the red, green, blue, and alpha channels to do nothing, as those channels are from the Beauty Pass and can remain as rendered. But now I'll switch to the auxiliary channels and enable the extra channels. And I will map the X position to the red channel using the foreground input. Y position is mapped to the green channel, and finally Z position is mapped to the blue channel. That's the first step. First, I'll give you a visual representation of what's actually going on inside the Volume Fog tool. Let's start with the Fast Noise tool. We'll set the image width and height to 256 in the X-axis and 256 in the Y-axis. The Volume Fog tool also expands the data to 256 in the Z-axis. We effectively create a fast noise cubic volume of 256 in the X and Y and 256 in the Z. In terms of memory, this 256 times 256 times 256 cubic volume will eat up about 2 gigabytes for a full color 32-bit float image. Now for the fun part. From the Tools menu, select Position Tools, Volume Fog. Based on the default setting and depending on your scene, you may already see the beginning of your volume fog effect. This may not always be the case, and it's dependent on what X, Y, and Z positions are visible on any specific frame. If you don't immediately see the volume fog result, use your eyedropper translation pick tool and drag around your Beauty Pass render. Your volume fog will be exposed, which includes the ability to take advantage of occlusions in 3D space, an incredibly powerful advantage. The Volume Fog tool also has an optional 3D scene input, which needs to contain 3D camera information. Even though camera data is not mandatory, it is certainly more beneficial for a more accurate evaluation of the volume. This data can be accessed through a couple of different methods: importing specific 3D camera data from a 3D scene such as an FBX, or direct data ingest from Fusion's 3D camera tool. Either way, you'll need to connect the camera to the 3D scene input. If you use FBX to import the camera data, you'll end up with a 3D merge in your comp attached to the camera. You won't need the 3D merge, so just delete it. Here's what's in the Volume Fog tool. Your first tab controls the shape and the geometric translations of the fog. Your shape options are rectangle or sphere. Below the shape toggle buttons, you'll find the transforms and translation sliders to move, rotate, and scale your fog in true 3D space. You are able to manipulate all these modifications in 3D because the effect position of the fog is derived from the World Position Pass. This is the power behind the Volume Fog tool. To further control the look of the edge, there's a soft edge slider. Don't forget that most tools in Fusion go beyond the factory default of the slider's minimum and maximum settings. For example, if you want an even softer edge, just type a larger number in the number entry box. We'll now switch to the Color tab. Don't let that name fool you. This tab controls much more than just the fog color. Yes, you can control the self-explained image controls such as color, the overall gain for a more or less intense looking fog, as well as the additive and subtractive slider, controlling the merging method for the fog, which depends on whether the fog image is post-multiplied by alpha or not. Now take a look at this. The volume fog effect has a second image input. This is for another image sequence that will allow you to create volumetric fog with varying depth and extent. Here's an example on how to use it. Let's use a fast noise creator tool and set the image size to 256 in the width and height. As well, set a high seeth rate to force a sequence of different images when the fast noise tool is played. Now connect the output of the fast noise tool to the second input. Immediately set the Z-slices slider to 256. As shown in our earlier example, this is how the volume is created from the image sequence. Now based on the look that you use for the fast noise tool, denotes the look of the fog. Experiment with higher seeth rates as well as brightness, contrast, and color for different looks. Try combining multiple fast noise tools combined with masks and compositing them in different methods for interesting results. What you'll notice is that after each change to the source fog image sequence, the Volume Fog tool will have to recalculate the volume multiplied by the number of Z-slices you set. If you have enough memory, the Volume Fog tool will cache the volume and only render the new frame. If you don't have enough memory to store the volume, it'll need to be recalculated on every frame, impacting performance. The first slice time slider denotes the frame in which the image sequence begins. In most cases, frame 0 is fine. The sample slider can be compared to ray tracing samples within the volume. The higher the number, the more accurate the volume. Make certain the global end time is set to a high enough number to encompass both the length of your clip plus the Z samples in your volume. In our example, our source is 119 frames and our Z-slice count is 256. Therefore, we require a global out of at least 375 frames, or else the Volume Fog tool will fail. Experiment and have fun with different types of animated images to create unlimited variations of fog. Coming soon in Fusion 6.3, the Volume Fog tool will take advantage of lights contained within a 3D scene. I'll have a tutorial on volume lighting soon. For additional information, see eyeon's tutorials on Fusion's other position tools. As always, for more information on the Volume Fog tool, consult eyeon's VFXpedia site at vfxpedia.com. Thanks for watching this short presentation on Volume Fog, and we'll be compositing with you and Fusion next time.